Welcome back guys. This is Ashwin here. In this video we are going to see about SMS spam detection analysis. This is an NLP classification problem. So this is like a basic NLP problem which is very popular. So it can be SMS messages or email spam detection. There are various spam analysis going on in various fields. So today we are going to do it. So apart from this, we are going to introduce some new way of doing the text analysis. So I'm going to introduce some pipelines which can be used for any other ML models. That will be the new part here. As usual, we have to do all the necessary pre-processing and loading the data set, everything we have to do. So we will do it in a simpler manner because the data set is like very small. We have like 5,500 samples only. After this, we will be going into some deep learning part. In the deep learning, we will be having so many number of samples and we'll be using bigger models, and the pre-processing and the whole pipeline and the entire flow of the project will be completely different. We will see that in the future videos. For now, let's go into the project. First, the dataset information. The spam concept is diverse. Advertisement for products, website, make money fast schemes, like that. There are many spams are still going on even in this era. So in the spam collection, we have a set of SMS tagged messages that have been collected for SMS spam research. So it contains one set of SMS messages in English of 5,500 messages tagged according being ham, that is legitimate, or spam. So we have only two columns here, that is one is the SMS messages and the other one is the label, that is spam or ham. Okay, let's import the modules quickly. We have to import the basic modules. Import pandas as PD. So in this data set, we are not going to do any numerical analysis. So I'm not going to import numpy here. We need a NLTK module. So we will import that NLTK. And here we are not also covering the visualization for the text analysis. I have already done some visualizations for the text in Twitter sentiment analysis. If you didn't watch that video, means you can click on the right top corner. You can have the video link. And for cleaning the text, we need to import regex, that is import RE. Apart from this, we'll be importing some modules later on. For now, we will just import another one, that is stopwords from nltk.corpus import stopwords. Let's run this. So it will take some time as the modules are loading for the first time. We will just load the dataset now. Now the modules have been imported. So for loading the dataset, df equals pd dot read csv spam dot csv, and we will display the head. So we have here. So in the data, as you can able to see, by default it has some null values, and this is the column we need to have. We will just take these columns only. So for that, df equals df of, again a square brackets. So in the square brackets, we'll be having the columns. First, we need the input. So that is V2, SMS messages. And finally, the label, that is V1. Now, even after this, we need to have some meaningful names for the columns. V2 and V1 is not that much meaningful. So we will just change the column names. df dot rename columns. It's automatically changed. Columns equals. So the column name will be V2. That will be changed to, I will say, messages, and another column name that will be V1. I will treat it as label. Okay. And you can also use in place equals true. it will change the effects in place, so we don't need to assign anything. So you can able to do that, or else you can also do it in this way. That will be df equals df of rename all this thing. So both are doing the same stuff. So you can able to do it in two ways. So after this, df dot head, run this thing. So as you can able to see, we have got our messages and the label column. So it is much more simple and clear for us to see now. So this will be get necessary columns for processing. Okay. So in this, we don't have much of exploration for df.describe or df.info because we have only two columns. So we will directly go into the pre-processing step. First, as usual, just check for the null values. Check for null values. Df dot snull dot sum. Run this. So we don't have any null values, fortunately. So it will definitely ease our code development. After this, we definitely have to pre-process this input. So to ease our process, we will just define some function called clean text. So def clean text. So we will be passing the text here. Now we need to do the pre-processing. Text equals text dot lower. So we need to convert all the strings into a lowercase. So we can able to process the common words. Sometimes if it's lowercase and sometimes if it's uppercase means there will be some kind of mismatch even if it's the same word. That's why we are just converting into lowercase. After this, we are going to remove some special characters if it's exist in the text, but we are not going to remove any numbers because if you see some other text processing, like even in Twitter sentiment analysis or text summarization, anything, we will be removing all the numbers and the special characters. But here, sometimes most of the spam messages are related to some lottery or some big cash prize or money. That's why I'm just including numbers also. So that will add more insights for us. So for that, text equals read.sub. We need to have the format that will be, we will ignore 0 to 9. So we need to have 0 to 9, A to Z, and also capital A to Z. So we will be replacing that special characters. This means excluding this thing, whatever it is remaining, just replace it with space. And we are doing with the input text. So it will replace everything and store it in text. And also we have to remove the stop words. So for here, I'll just add another thing. Because stop words don't need to be computed again and again. So I'll say stop words equals set of stop words dot words. We are dealing with English language, so you need to pass the parameter as English. So it will get all the stop words as a list here. And in the text, we are going to join everything. And here inside it, we will just go with the for loop. So I'm just using some single liner. Just watch carefully. So first we are going in a loop. So for word in text dot split, it will just split the text. And if word not in stop words, So if the condition satisfies, we will join the stop words in the text. So first it will go into the loop and it will get each word, and we are checking with the condition. If the word is not in the stop words, it has some original meanings. So we will add that word to the original text. So after doing this processing, we will return text. So using this kind of functions is very much easier, because while processing some kind of real-time data or the test data, it will be easier. You just need to call a single function, or else if you are doing it by line in a separate cells means it will be a tedious process. That's why I just used it as a function. Let's run this now. Now clean the messages. So for this, we will create a new column, df of clean text equals df of messages dot apply. So to call the function for each row, we have to use the apply function and call the function, that is clean text. Sometimes if you press tab, you will get the suggestions for the functions. So after this, we will display the head and this. So we have done it. Yeah, I guess it didn't remove the numbers, but it just converted the every string into lowercase. So that works better, and it also removes some of the stop words, that is this only or some other. See, this 2 is removed, and digits are there. So instead of using like this, maybe we will just add a bracket here. So I'll just comment this, convert to lowercase. So this will remove special characters, and after that we also remove additional spaces, remove extra spaces. So for that we will add another regex, re.sub, or that will be backslash s plus, and we will replace with a single space and the text. So this will remove extra spaces, this will remove stop words. Okay, let's run this again. Okay, I think it's showing some error in stop words because I use the same uh, words here. So maybe we will just change it to uppercase. So stop words, because this is a function and this is a variable, so it just confusing with that. So now it will be good. Maybe we will just run everything from scratch. So it's running fine now. Let's run this again. Now it's good. Yeah. So as you can able to see, we have removed these additional dots, and we don't have any extra spaces. So usually this dots will be converted into some spaces, and we have removed the extra spaces using this line, and we also removed some of the stop words. So that will be this two. So here it is missing, and I is also a stop word, that also missing, and don't is also a stop word, that also missing. So we have cleared everything. So this is the pre-processed text. So it's better to do it in this way because we don't want to lose the original value. If we want to do some processing after that means it will be very much easier. For training the data, we can just have this clean text directly. So it will be easy as that. Now, after doing the pre-processing, we have to split the inputs. So usually we will be doing some label encoding with this ham spam. We have to convert it into some zeros or ones. maybe for this time, let's try it as it is because I tried it with some other data set. It also accepts string values in the output columns. Let's try it out now. If it's not working means we have to use the label encoder and convert these string values into numerical, or else you can also use some dictionary. So let's split the input now. So x equals df of clean text and y will be df of label. So this is our input. Let's leave some space and we can able to create some function and do all the things in a function itself, or else you can able to split the data using train test splits and do it accordingly. So for now we will just go it in a easier way. So that will be creating a function because that saves a lot of time for us. For that we have to import few modules now from sklearn dot pipeline. We have to do some feature extraction. I'm just combining the feature extraction also in the same part here. So just watch carefully. Import pipeline, and after that we have to import train test split. So that will be from sklearn dot model selection, import train test split and crossval score 2. So now we have to import some feature extraction modules. That will be from sklearn dot feature extraction dot text import count vectorizer tf ids vectorizer tf idf transformer. So in this project, I'm going to use count vectorizer and tf idf transformer. That is like a two separate feature extraction technique. Combining both of these two will give much more better results, or else you can able to do it individually also. You can able to extract the features using count vectorizer alone and can able to do the classification, or else you can also use tf idf vectorizer alone to extract the features and do the classification. So this will give some extra results. So this pipeline will give you different feature extraction techniques. That's why I wanted to show you. Now def classify, we will just pass the model x and y. Now after this, we need to split the inputs for training and testing. X train and x test, y train, y test equals train test split of x and y. Test size will be, we can go for 25% itself. So that is our usual number. And we will just go for a random state equals 42. So we can able to keep the results as it is. And here we will add another module that will be shuffle equals true. So it will shuffle the data, or else it will just split it accordingly. And for equal distribution of classes, we will use stratify. So that will be the output value, that is y. So this is train test split. After that, we need to train the model. So model dot fit. So this will be train test split, and this will be model training. We will train with train data. So that will be x train and y train. So after training the data, we will get the results. So that will be print, go for accuracy, accuracy. So to do that, model dot score x test and y test. So this will give us the accuracy. We'll multiply it by 100. So that's done. After this, we will get the CV score. So CV score equals cross-val score of, we need to give the model, and we have to pass the input and output parameters that will be hold training data x and y, and we can set the CV size as CV equals 5. So that is another parameter. You can also able to change to 3 or 7. It depends on your analysis. So after this, we will be having a list of scores. For that, print CV score, that will be, we already missed that numpy module for the mean. Import numpy as np. I think it's better to import these first two modules, that is pandas and numpy, because anywhere it is useful. Now np dot mean of CV score now multiplies by 100. So this will give us a generalized score. Now this is the default function we will use for all the classification modules. So now we are going to do the feature extraction by in the function itself. So for that, so we will go for pipeline model. So pipeline model equals, we will build our pipeline now. Pipeline of a list. So in this list, we are going to specify each term. First will be the count vectorizer. So in the brackets, first we need to give some name. I'll say it as vect and give the count vectorizer. So this is our first module. After this, we will go for the second one. So that will be TF-IDF and TF-IDF transformer. So transformer only works. So here we have to, okay, we have to remove this and add here, comma, and lastly, we have the model. So that will be classifier CLF. We already passed the model, so we just pass the model here, and that concludes our whole pipeline. So what it does is it will extract all the features using count vectorizer for the first phase. So currently we are having the text, so we are just passing the text directly. So after extracting the features from using count vectorizer, it will transform using a TF-IDF transformer that will use the algorithm for TF-IDF, and it will give you another feature vectors. So finally, we will do the classification of the model. So this is our whole pipeline. So we will just replace the pipeline here. And for this, I don't think this cross validation will work. So I'll just comment it. So if you want to do the cross validation, means you can able to do the count vectorizer or a TF-IDF transformer in a separate cells and pre-process it separately. For now, I'm just using it in a different way. That's why I just opted for this method. So we will just check the accuracy of this model. Run this. So yeah, here I missed one comma. Let's run it again. Now it's working properly. So first, as usual, maybe we will use some basic model, that is logistic regression from sklearn dot linear model import logistic regression. Now model equals logistic regression. Now classify. We have to pass the model, input, output. Let's run this. Okay, it's showing some error. I think it's because of the data type. Okay, again here I think I didn't use the pipeline here. That's why. So let's run this now. See, we didn't use any label encoder here. It automatically accepts the string for the output alone. So it's giving around 96.8. That's a good accuracy for us. And maybe we can have the classification report, but for that we have to do the prediction also. Yeah, let's do that now. In the model selection, do we think we have the classification report? Classification underscore report. I don't know whether it is there. So I think it's not there. Let's import metrics from sklearn.metrics import classification report. Yeah, it's there in the metrics. Now at the bottom, what we are going to do is get the prediction of ypred equals pipeline model of xtest, and finally we will print the classification report of ytest comma ypred. Run this now. Pipeline is not callable. Okay, we have just missed the predict. Well, in this project we are missing so many things. That is me. Okay, we have the classification report. Now let's see, we have so many genuine values, that is around 1200, and for spam we have only few labels, that is 187. Out of this we got around 97% accuracy as the average, and the precision and recall is also good, so it's better. So again, a few tips is for text analysis problem or text classification, the most common modules used is naive Bayes, SVM, SGD, similar kind of modules are used. Because these naive Bayes and SVC, it's performing way more better than the other algorithms based on some research done in like maybe 2 to 3 years ago. So we will just use those algorithms now. So for that, from sklearn dot naive Bayes import multinomial NB. We have so many algorithms here. Let's maybe see that. See, we have categorical NB, complement NB, Gaussian NB, multinomial NB. So for now, I'm just going to use multinomial NB. You can able to try out different models if you want. So model equals multinomial NB and classify. We will pass the model X and Y. So here there is a little drop in accuracy. Maybe we will just change it quickly to Gaussian, whether it is working good for Gaussian. Okay, it's not even supporting, I guess. It's expecting some sparse matrix for needs to be passed. Let's revert back. You can able to change it to two array, like dot two array like that. You can able to change it. For now, I'm just leaving as it is. So another good module is SG declassifier, that is from SVC. So from sklearn dot svm import. We have so many SVCs, so I'll just go for SPC, and the same, we will just initialize and classify model comma x comma y. Run this. See, SVC is performing way more better. That is around 98%. So in the logistic regression, we reached around 97. If we see the actual numbers, that is 96.8. Here it is 96.6. Here it is 97.9. So that is way more better. After this, we can able to try out various algorithms if you want. So maybe I will just go for one more complex algorithm, that is random forest from sklearn.ensemble import random forest classifier. So this is one of the complex algorithms. I think it will definitely give you some higher results. So let's see that whether it is giving or not. Hope this will give us a good result. Okay, it failed us. So this is the top performing model for us, 97.9. We didn't even do any kind of hyperparameter tuning. I have covered hyperparameter tuning in a separate topic. Maybe I will just change a few things here. Maybe I think C is one parameter here. Say 5. Okay, it's an unknown argument. Okay, now it's working. Okay, now I just changed only one parameter. It just gone up to 98.2. Let's change the values more, like 10. It just oscillating there only. 98.27. Yeah, I think this will be our final score. Apart from that, we have reached pretty much good results. We didn't do anything. So far, you can able to see this is like, if I didn't explain all these things, it will hardly take 10 minutes to complete the whole projects. So we just dropped out some visualizations because in the text data, maybe we will just see some common words that is also removed using the stop words. So I don't think text analysis will be much helpful. Maybe you can able to visualize using some word cloud and filter out the data for ham and spam and see what are the common words that are occurring most frequently. So that analysis you can able to do. So I can leave this to you guys. And apart from that, we have seen how to create a pipeline and do the feature extraction in place. So that is the new thing I have added in this project. And it's pretty much good. By changing a simple hyperparameter, we have just improved some accuracy for the SPC. So based on my experience, I think these two modules will perform very much better for the text data. You can able to, if you are trying to go for some text data or text analysis in any project, for machine learning, I'm saying go for this two modules. At least consider these two modules in the list. So that's it for this project. I will cover some more text analysis during the deep learning part, because that will give us more context compared to this machine learning, because we are just going in individual word basis, not in the whole context, that is sequence to sequence. We'll be covering a lot in deep learning section. So we will wait for that. And I think that's it, guys. If you have any more methods to try out, or if you have any suggestions to add to this existing projects or in the future projects, please leave a comment below. I will definitely try my best to incorporate all those doubts or all those improvements in the upcoming projects. And if you like this video, hit the like button. Don't forget to subscribe the channel for future videos. Stay tuned for the next video.